So welcome everyone. Thank you for joining Data Engineering San Diego. My name is Dustin Vanoy, if we haven't met, which I think quite a few of you I have not met yet. We also have Ike Ellis, is a longtime member, a longtime connection and someone I work with, but he's now a co-organizer, co-host of the meetup. Do you want to say hi real quick, Ike?
I do, yeah. Hey, thanks for having me, you guys. I've loved the group and I've loved everything that Dustin and Andrew have done with it. And I'm just grateful to be a part of it still and eager to help in any way I can. So thank you so much, you guys.
All right. With that, I will do a very quick introduction and let him fill in the gap. So our presentation tonight comes from Itai, who is a software developer within Treeverse, the company behind lakeFS. And so he'll be talking to us about the types of problems that lakeFS solves. lakeFS is open source software, and then Treeverse will probably share a little bit about where they come into play besides committing a lot of code to it. So with that, I'll turn it over, and I may chime in from time to time just to help with Q&A here. Thanks for joining. Itai, the floor is yours. We can see your screen. I'll let you know if you're muted still once you start talking. Take it away.
Thank you, Dustin.
Hey.
Hello, everybody. As Dustin introduced me, I'm Itai. I'm a software engineer with Treeverse, the company behind lakeFS. I'm currently based in Winnipeg, Canada. I'm coming from several years of development, mainly in the fields of storage systems and cybersecurity. And I joined Treeverse because I got really intrigued by the product they were developing. Got really intrigued by the open source nature of this project. And I really got intrigued by the people working on it. And again, as Dustin mentioned, we are an open source project with all the intention to stay as such. And let's get down to the business, and let's start by talking about data lakes. Today, data lakes are mostly based on the centralized object store, probably something commercial such as S3. The object store is very performant, very cost effective, absolutely all the good reasons to use it. And what usually happens is that you have your data source writing or streaming the data into the lake. You got your ETLs and the pipelines that transform this data and change it and write it back to the lake. And eventually you got your consumers, such as BI tools or the like, consuming this data and using it. By design, this data lake is a single source of truth, as we want it to, as we want the data to be available from the sources all the way to the consumers, and that brings up a lot of challenges. On one hand, it's quite impossible to test the data before it hits the lake. This makes the process very error prone, and erroneous data can arrive directly from the data source. It can arrive due to some buggy ETL or some broken pipeline or anything like that. It is very hard to test it, almost impossible to test it before it hits the lake. On the other end, once the failure does occur, and it probably will occur, it is very hard to revert back to a point in time where you know where your data was complete. This makes the errors very expensive, and the process to fix them is usually a manual process that takes a lot of time and a lot of effort. Over that, if later, once you recovered, You want to debug and tackle the problem that brought you to that state to start with. It is also pretty hard to get back to the data set that had the problem and to work with him in order to debug. We face the challenges in every stage of our work. Okay, during development, we lack the ability to test our code, right? We develop some new pipelines, some new procedure that transforms the data. I don't know if the data is good enough. I cannot test it on the production, and if I test it on the production data, I may break it. What usually happens is that you create a local copy of either all your data, which is very, very expensive, both in terms of time and space, or you just test it on a subset, which is not covering the entire spectrum. During deployment, we have difficulties to make sure that what we deploy, it really guarantees a good quality of data. And once we hit production, as we already mentioned, when things go wrong, it is very, very hard to revert from a corrupted data and all the way to a good point, to a point in time where the data was good to use. We are familiar with these challenges from the world of engineering, software engineering. These problems are long solved. We have CI/CD tools and version control, but apparently we don't have this for data. That's what we're trying to do with lakeFS. We're trying to manage our data the same way we manage our code. If you ask our users what lakeFS is all about, at least 99% of the users will say lakeFS is Git for data. This is definitely where we're aiming because we really like Git. We really like what Git does to code, and we really like our data. lakeFS, in one sentence, it turns your data lake to a git-like repository. Okay, lakeFS lies on top of your object store, actually between the object store and the using apps. And it provides the object store with the capabilities that we believe it misses in order to become a Git-like or a Git repository-like object store. It's designed to act as an S3 gateway. So all compatible apps that currently work with the S3 API can easily work with lakeFS. It's a matter of simply changing the endpoint and introduce the concept of the branch that we added. The using application can access the data either via lakeFS, or they can bypass lakeFS and continue working directly with the object store. lakeFS does not prevent you from keep working with your object storage directly. And in fact, we have developed a Hadoop client that does actually that by using lakeFS just for the version management, but the data itself is written directly to the object store. lakeFS adds branching capabilities to provide the isolation to your experiments. It provides atomicity to ensure your consumers are not getting partial data during deployment, and it provides the ability to revert and recover easily when things go wrong, but it's a bit more than that. If you think about it, GitHub is used for CI/CD, and versioning is a requirement for CI/CD. lakeFS can also be used for CI/CD on your data, and it provides versioning as the requirement. Okay, so the way to move from accessing S3 directly to accessing S3 via lakeFS is by simply adding the branches you can see here. And that's a snippet showing our CLI. We'll see that later in the demo, which is very intuitive, very Git oriented. So lakeFS, as we said, it exposes an S3 compatible API. So all your S3 compatible apps can easily work with lakeFS the same way they work with your object store. Just a matter of changing the endpoint and adding the branch. The rest of the work remains totally transparent to the application, which is very important. Our API, as we said, it adds the versioning abilities supported obviously by our versioning engine, branching, committing, merging, reverting abilities, and your data lake gets those Git abilities and becomes Git-like object storage and possibly a part of your CI/CD. It does important to remember that while Git is designed for man-scale usage, and by that I mean code written by people, and the scale is appropriate, lakeFS was meant to deal with machine load and machine scale data, which is orders of magnitude larger. And beside that, it also sort of meaningless. Let me explain. While code is easily interpretable and it's very easy to compare two files and understand what the difference between the files, with data, it's sometimes or even mostly impossible. We are not format aware. We are totally format agnostic. You can use lakeFS to version control all the formats, even images, videos, binary files, everything goes. We do not look into the files. There is no need. Development best practices with lakeFS. We talked about reverting bad data instantly. lakeFS will provide you with branch revert with just a single command in our command line, lakectl. It's the command line tool, the control tool of lakeFS. And here you can see how I take a branch and revert it to a certain commit ID. We introduced the concept of a commit. We introduced the concept of actually a commit is a snapshot, right? And when you have a bad snapshot at your data, you just revert the commit that changed it back to a previous commit. If you want to expose new data in atomic form, it can even be a cross collection. It doesn't have to be limited to a single collection. You got the merge command when you merging your branch into the main branch. The main branch is the usually the name of your production branch, right? Sorry. You want to develop in isolation, you can branch out of the current production, get a copy, which is not really a copy, right? You get a branch who's identical to the production data where you can experiment, you can change, you can test, you can do whatever you want, and it's isolated, no effect on the main branch, just like Git does with code. And later on, when you want to reproduce some problem you saw in production and easily and successfully reverted from. The commit is still there. You can easily consume the same data that was broken and work on it again in an isolated branch safely without hurting the production data. If we go back to the data lake challenges we saw earlier, and we'll try to see how lakeFS solve it. So in development, using isolated branches, you can test your pipelines, you can test your data, you can test how they work together. You can collaborate with parts of your team on the same data. Very, very similar to what Git does with feature branches and code. During deployment, you can guarantee the data quality, again, by using isolated branches and our hooks. lakeFS support pre-merge and pre-commit hooks, where you can run your test and complete the merge only if the test went successfully. We have a couple more hooks and more hooks in the works. And in production, if you're asking me, that's the highlight. Once things get broken, you can easily revert. As we saw, it's a single command for single command line to revert one commit back to a good point in time, and everything can be back in its order. And later you can also use the corrupted data, which is still there, to debug the problem and understand what went wrong. So a typical environment would probably look like that. You got your production branch, your main branch, okay? And you probably got some ingestion branch where new data arrives. The data is considered dirty as it's not tested yet. You can run all kinds of tests and operation and verify that indeed that's the data you want to introduce to your main branch, main production branch. Once you're satisfied with the data, you just merge it. You can use the pre-merge hook. The pre-merge hook, and it's important to distinguish, it's been run on the merge data, but before it gets into the production branch. You can cancel or avoid the merge action into the production branch if the merge hook fails. That can protect you from a lot of possible problems. And as I said, you can also use pre-commit hooks if you want to have the same protection between the commits on a feature or ingestion branch. You have post-commit and post-merge hooks that can trigger a revert action, for example, if something did get broken. Matters of all kind of consideration of scale. And as I mentioned, we are working on improvement to these hooks, and new hooks you will be able to catch as branch creation and data upload and stuff like that. And if we continue, usually when you want to try a new feature, you can branch out from any point of any branch. Ideally, it will be from the production branch, right? Because you want to get a copy of the production where you know the data is production quality, where you can experiment and you can commit various changes and you can test. And if currently all you are doing is code work and you're not looking to change it or transform your data, You don't even have to commit it back. You could just throw the isolated branch and merge your data in a real code Git. Obviously, you can branch in parallel from whatever commit you would like to work. That might be an example of wrong data set that was branched out in order to debug it. Things like that. The thing is, and we'll see it immediately in the how it works, is that branches are very, very cheap, same as with Git. Let's look inside. So just to be on top of things, that's I would say a very, very high level of our architecture, right? We got the S3 gateway leading into our lakeFS server. Applications can be like consumers, producers can either use the lakeFS S3 gateway, talk to lakeFS the same way they talk to an S3 storage, and let everything pass through lakeFS, or they can use our Hadoop client. Spark does it. Use our Hadoop client to write directly to the object storage and use our server just for metadata operations. The metadata also sits in your object storage as a KV store. A couple of things worth noticing, because we're really striving to stay there. Your data is being deduplicated. We will not copy anything of your data. lakeFS does everything on the metadata level. It has all the benefits in the world and no disadvantages, and that's where we're aiming, and that's where we are. Here's a good example of what it looks like, what a commit or a snapshot looks like. Eventually, a branch is, I would say, a chain of commits, right? It's the current commit and its parents. And in lakeFS, a commit, which is a snapshot, is basically a collection of files. The commit itself is represented by references to the file. We call that a range, and it's a metadata only operation. So if in that, if you look here at that point, this commit is a set of references to files in your bucket, data files, and you change two files. What happens in the object store, you actually upload two new versions of the files. These are two new files. And once you committed, a new commit object is created with reference to 5 files, where the 2 updated files are now pointing to different files. The lakeFS operation here, the entire commit is solely metadata. No data is being copied. The files you see, the identical files that weren't changed, are the same files that you see in the previous commit. It's super efficient. It's very, very quick. Actions like branching are practically zero cost. The magnitude of our metadata is much, much smaller than the actual data. And it's worth mentioning that aside from the fact that the metadata is immutable, which help us keep the commit history and later on revert or check out from a previous version, all the operations are copy on write. So again, once you create a new branch, nothing is being copied. It's just a new reference to the same commit. If you're branching, for example, from this commit, you will have another reference to that commit. It's a metadata only, and only once you will make some changes and create a new commit, we will start creating new objects. It's super efficient. It provides great performance, especially on big data lakes, where big data lakes, a very, very small percentage of the data is being changed on every time. And the work with only metadata that only represent the changes make all kind of very heavy operation like diffing between two versions or even merging, they become metadata only operations and are also done very, very efficient and very, very quickly. Last point, it also saves you a lot of space. And while we mentioned that the object storage and S3 are really not expensive, they're absolutely not free, and you can also gain the benefit of saving space. Questions so far before we go to see a quick demo, see it in action?
We have one in chat by Edmondo. Edmondo, would you want to unmute and ask that question? If not, I can try and read that out here.
Thank you, Dustin. And hi, Itai. This is very interesting, but I see this approach of working with a data lake at file level as one of the way you can work with the data lake, but also not the way that maybe vendors like Databricks, they are suggesting you should work with. They are rather suggesting that it's much better it's much easier if you convert your file, you register your tables in the Hive meta store, and you work with a higher level of abstraction. And especially if you use Delta Lake as a storage format, you can, you have time traveling, Delta time traveling, so you can still go back. I see value in a solution like lakeFS a lot. I just wanted to understand, when do you think working with files is better than working with tables and using a solution like Delta Lake?
First of all, thank you. That's a great question, and I didn't touch this point in my presentation, but here is the chance. Let's take it. Data tables are a format, and our lakeFS is format agnostic. You can also use it over data tables. We have all kind of cooperation with all kind of formats, and once anything in the I would say anything in the way we work with different clients or the way different clients work with us, if there is a need and there is a request, we usually try to adapt it. As I see it, as lakeFS, it's just a different level, right? Like a different level of abstraction. You can definitely use lakeFS with Databricks. It shouldn't break you. Regarding working with files or with data tables, I believe it's pretty much up to you and up to your use case. We can support both. Does that answer your question?
Yeah, okay. Yeah, the code you show was all object based, so I think it would be interesting to see some code example on what does it mean to use lakeFS when working with underlying tables underneath.
I'm not a specialist in that specific area, but it should be pretty much the same. Again, lakeFS treats the entire data as objects. You change an object, you get a new version, you commit, you get a collection of references. Eventually, everything is backed up by objects, right? By files.
Yes.
So it should be totally transparent, almost transparent, if not totally transparent. I can definitely verify that and return with an answer.
Thank you.
So we have we have another question in chat from John about how does this vary from standard S3 versioning? And I guess just also confirming, is S3 versioning used at all in the implementation?
Yeah, that's another good question, which was asked during our work too. What do we do different than S3, or even better, where do we add on S3 versioning? Now, S3 versioning is on an object level. You can take a look at the history of your object, but you are lacking the concept of the snapshot, because if your data changes multiple objects, S3 will not help you unless you want to go and change them one by one. Sure, you can use scripts and things like that, but it will make your work a lot harder. Again, you don't have the concept of snapshot, the concept of a commit. With lakeFS, you will have it.
Are we going to be able to see kind of a little bit about what's happening in the storage in this demo? I don't know how under the covers you're able to take it. Seems like there's some questions around kind of how it actually is working to help us get our heads around it.
I wasn't planning that. Basically,
why don't you keep going with what you got? We'll follow up with questions towards the end.
Let's see how it looks on the higher level.
Okay.
Let me share.
Excuse me, can I ask a question before you go into the demo?
Yeah, sure.
So I just had a question on for lakeFS, because it seems that it only supports the object storage in the public cloud. So if someone wanted to do it in the on premise, can they use? Are they out of luck, or would it like support, say, S3 compatible object storage? That's on like Nutanix does that. Would it be able to support that, or it's really just public cloud?
Not only you can support local storage, you can also run it on like a demo level, not the production level. We're just storing thing on your local CD. It's a local hard disk, sorry. It's definitely an option, and our getting started guide even allow you that option.
Oh, okay, I'll look for that then, because I haven't finished reading the documentation. So, okay, thanks.
Okay.
Itai?
Yes.
Can I jump in with one thing?
Of course, always.
So first of all, yeah, just to make sure that everything that supports S3 lakeFS works against anyway, like Min.io or Nutanix or anything that has S3 storage will work with on-prem. Actually, to me, it was surprisingly common. It was exactly more common than what I expected, to be honest. coming from the cloud. The other thing, just to circle back to Delta Lake, and to an extent with to the versioning question also. So Databricks, which by the way we work great with Databricks, and we have some video, like I think just last week or maybe 2 weeks ago we had a joint webinar with Databricks about Delta Lake and lakeFS together, which we can find that also and share it with this team if you want. But Delta Lake will give you time travel for a specific table. That's correct. But there's 3 things that it doesn't do, which is the time travel in the holistic view of the entire data lake or the entire repository, which repository is whatever you want it to be. So if you think of the very first thing, that million moving parts that Itai showed, like, okay, so one table changed, but what other tables change at the same time? The second thing is, and I think I can't stress this enough, the ability to work in isolation, right? So creating a branch and working it and then throwing it out or whatever, that time travel helps you undo bad changes, but doesn't help you work in isolation concurrently with a lot of people. And the third thing is the hooks that we mentioned. So it's very difficult. It's very different. Having said all that, we're very excited about open table formats such as Delta and Hoodie and Iceberg and others, because if you think about it, Delta actually keeps the log on the object storage of the actual changes between table and table. And what we have on our roadmap, which is also a part of the open source project, and you can look at it, is the ability to, when you compare changes, for example, between commits, if you have Delta, then you can actually utilize that log and see more than, oh, this object changed, that object changed. You can actually see exactly what changed, which is very exciting, and that gives us the ability to integrate even more strongly with open table formats. Sorry, I hope it wasn't too long.
It wasn't. Thank you, Ido. Ido is working with me at Treeverse, if that wasn't clear. Thank you. In the meantime, I shared my console, and what we currently see is it's the web UI to lakeFS. I prepared a repository, named it demo repo. It has currently a single branch, the main branch, and up until now, all I did was to create the repository, which is one commit, and to upload some data and commit it. The repository being created is being committed automatically. The data was committed by me, and currently I have a single Parquet file with some user data. Nothing special. I found it somewhere on the internet and downloaded it, and we're gonna work on that with our Spark client that sits on my local PC, and we will work on the lakeFS that also sits on my local PC, but by changing the endpoint, I can reach any lakeFS in my network. So here I'm going to start at the shell. I'm going to start my Spark client with a couple of parameters that are required to allow me to work with lakeFS. Once you create your lakeFS setup, you will get 2 keys, an access key, a public access key, and a secret access key. Very similar to what AWS does with its IAM users. Obviously, if Spark wants to get to our lakeFS, it needs those keys. So we specify it over here. This is the public key and the private key. The configuration, we allow path style access. And the last thing we need to remember is to redirect the S3A endpoint to our local FS, local lakeFS. Okay, let's start. And the next thing I'm going to do, I'm going to read this Parquet file. Okay. It's located at S3A, our S3 gateway. The path is demo repo. That's the URI to the repository. Sorry. The branch is part of the URI and the file itself. And here
You see it, it's that the first beep of will help from the chat over here.
The amazing abilities of copy pasting. Thank you.
That's why you have people watching you.
I'm glad I was able to find it that quickly. And if we look at the data frame we just read, it's just a table with 10 users and their details. Now, what I want to do, I can work directly on the main branch. I don't want to work directly on the main branch. So what I'm generally going to do, the first thing I would like to do is to protect it. I can protect the branch. I can add it here, call it set the main branch, and that will block lakeFS from allowing you to make all kind of commits to the branch, all kind of changes to the main branch. You can make merges to that branch, but no uploads, no deletions, and no stuff like that. And the next thing I want to do is to create a new branch. Okay, now I'll create a new branch. I'll name it testing, as I already did before when I was rehearsing that demo. And at this point, you can see that both main branch and testing branch sits on the same reference. That's the commit that they are pointing to. If we go and look at the objects, we will see that both the main branch contain the user data file, and the testing branch contains the very same file. And actually, there are no two files, right? There is just a single file pointed by both. I can also read the same data. If you read it from the testing, I'm only reading 10. This is a huge file. I'm only reading 10 entries. And once again, we'll show it. We'll see it has the very same data. It's the same file. Now, the next thing I want to do is to run some Spark job. Write it to the to my testing branch, right? And here I'm partitioning the Parquet file by the country column. And if I will go over here and I will look at the files created by the Spark job, we'll see that the Spark job is ended successfully, lucky to me, and we got the partition by country as we wanted. And if I'll go to the main branch, those files are not there. There are no uncommitted changes in the main branch because my testing branch is isolated. Okay, if I'll go back here, they're still here. Now, the next thing I want to do is to commit these files. Let's say I'm running some testing and I'm pretty satisfied with what I've done. Let's commit it. I'll commit it here. Very similar to Git. I can add my my message. I can add some metadata tags if later I want to search by some tags, some tag demo, and I commit the changes. And now there aren't any uncommitted files. And if I'll go to the objects, suddenly I got my partitioned by country folder, which exists on the testing, and still no such folder and no such files on the main branch. And at this point, I can go and compare the two branches. As you can see, we definitely know to identify that there is no difference between a branch to itself. But if I'll look at the difference between the testing branch to the main, it will show me that the right side, the testing branch, contains files that does not exist at the main branch. Now, let's say I'm done with testing and I'm pretty satisfied with the result. It's time to bring the data back into production. We're going to hit the merge. It's very fine with me. Are you sure you want to merge the testing info into the main? I'll say yes. And voila, no more difference between the two branches. But if I look at the commits tree, I will see that for the testing branch, I have 3 commits. I have the data upload and I have the data partitioned. And if I look at the main branch, I will see another commit, which is the merge itself. What else can we do? We can run another, let's run another Spark job and revert it. Let's partition them by email, by title. It's not the title, it's the this title. Sorry, my bad. Once again, the uncommitted changes are building up in our testing branch. And once done, we got everything here. We got the success. We can already see the objects under the branch, but it's still uncommitted. And at this point, I decided I don't want those changes. I simply revert them. Are you sure? Of course I'm sure. That's the whole purpose. And no new commit in the testing branch, no new commit in the main branch, of course. The changes, the objects are gone. Sorry, from the testing 2. And if we'll compare the 2 branches, the testing and the main, we see that there is still no change, no difference, because I did not merge anything. That's pretty much it. We can look, if you like, an interesting
Can I ask a few questions before you move on? Is that okay?
Of course, always.
So there's 2 main things, and sorry if I missed them. 2 main things I can't get my head around yet. When you have a branch, not your main, but you have like a working branch, the objects themselves, if you were to go look at S3 directly, are those files in that same S3, like that S3 path you're using is real? It just isn't connected to main through lakeFS yet?
Again, the S3 path almost exists. Sorry. Let me try and get my S3 real quick so we can take a look at that.
And I mostly just asked for curiosity about how it's implemented, but I'm also wondering, obviously people could potentially go and hit S3 directly if permissions are set right.
Yeah.
So what are they going to see versus those that are actually using lakeFS like you would want them to if you're using this system?
If in general, the file exists in S3. Once again, there is no double copies, even though all files exist in both branches. We also have some metadata in S3, which is not visible, obviously, as an object in our lakeFS. 1 second, please.
I mean, the objects are going to be managed. They're going to look differently in the lakeFS managed bucket, right?
Okay.
You're not going to see the actual file names.
And then this might be what, maybe that slide earlier was more literal than I realized. Is it like a GUID that's, okay, here we go. This is kind of.
All right, so what you see here, that's the objects loaded to the store. There are plenty of them here because I previously used this bucket for some experimenting, preparing to that demo. But we also have the lakeFS. That's our metadata. What we keep here is we keep all the metadata on the branching, on the commits, all those ranges we saw earlier in this slide over here. This data is sitting here among these files. I can't really interpret which is which, but that's the main idea. And under the bucket itself, you got the actual objects. These are the actual Parquet files. They're named by their hash values, which help us to create the deduplication, right? If you're now going back to a version that to a previous version by reverting a commit, we will just point to the file that is already exists in the object store, and we will identify it by its hash value.
So then, if you're to run a overwrite command in your test branch, you would end up with a version of the files for main and a version of the files for test, right? Even if it's the same folder name in your code.
If I now create, let's go here, and I'll create a new branch. All right. I hope that's what you're asking. If I create a new branch, this time I decide to go out of testing. Even better, I can go off a specific version of testing right after the file was uploaded. And I want to name my branch testing beta. And I create it. That operation where I have this branch over here with the Parquet file did not change the number of the files in my, the number of the object in my bucket. Okay. It did change the number of the object in my metadata because I have another branch now. Sorry.
But then if you were to do an override of that table, you would keep the old one until it's changed in main, right? And have a new one.
If
You'd
I now
have to, right?
update,
You'd have to have two versions of that file in your bucket in order for main to be different from your test.
that is correct. That is correct. If I'll now run the Spark job again and commit it, like the new Spark job, it will create new files. Let's do it. Why?
Okay,
Why
sure.
say what? Why say an if? So that's the job we performed earlier. All right, so I believe, okay, we got new files here. See, the number of files changed because the operation actually created new data files, right? If I look at my testing branch over here, I got the uncommitted changes. And I believe that if we'll count all the files, it will come exactly to the difference, which is 14.
Okay.
And again, I can commit it, I can uncommit it. If I undo, if I revert it, it will not delete it from the object store, right? We do have a garbage collection with a retention policy. You can define it here. By default, nothing is deleted. It's your object store and it's your objects. We're not going to delete it for you. Plus, we have a need for those files should you want to jump to a previous point of your data. But you can definitely revert a commit can also mean reverting a deletion, right? You deleted some files and now you want, and you committed that and you pushed it into production and now you want your data back. A revert will provide that due to the fact that the files still exist in your bucket and the metadata is still there. You can define a retention policy where all deleted files older than, I don't know, 30 days are removed from the, all unused files, right? Unreferenced files are removed, but that's up to you. You will lose the ability to go back that far away or further than that.
Okay. And then the other big question I had is when if I have a nightly job running on this, with this data, you know, pending data within the bucket, would that add a commit to main when that job runs? How do you typically manage that?
It pretty much depends on what your job is. Usually, if you want the data to be committed as part of the job, you can just define it. We do not commit anything implicitly. The commit is absolutely yours. We have an API that you can use to get those commits. We have clients for Java, for Python, for Golang, for HTTP API, Open API. So basically, whatever tool you are using, you can define jobs that as part of modifying data and introducing it, also committed. As part, you can use our hooks as I displayed earlier to test it before you commit and things like that.
And then just, I think this is the last one I have is that, so then the S3A we're looking at in your commands is actually calling a lakeFS library rather than your typical library that you'd probably have set for S3A protocol.
That's it actually does not use a lakeFS library. It used the I think it's the Hadoop AWS library. Okay. But it does point it to the endpoint I supplied it with, which is my lakeFS, which is local, so it sits on the loopback IP. But in general, you can use whatever lakeFS address you want. But okay. It's the
so you're
AWS
okay. I see what's going on. Cool. All right. What other question? Are you ready for more questions, or did you have anything else you thought would be good to share before we just see what people think?
No, the only thing I still would like to share, we have a portal. It's lakeFS.io. We have great getting started manual over there. We have documentation of practically everything, both for the users among us and both for the tech enthusiasts that want to deep dive into our code. We have a very, very active Slack channel. We have people responding there very, very quickly. We are very responsive. Most of the time, I don't know if most of the time, but a lot of the time, questions are getting answers by people who already experienced that and are outside of Treeverse, part of our community. We're trying to build a community of users / contributors / partners as we see them. As I mentioned, we are open source project, and we plan to stay an open source project. You can download our code, look inside, contribute if you want. We do have a managed solution, a hosted solution in the backend for those who needs it. You can see its demo in our portal. It has a link. You actually get a lakeFS standing setup in one click. Very, very impressive. And that's it. The last row is my email. Feel free to mail me with any question. I will do my best to either answer or at least to refer you to the correct answer. And that's it for me. Thank you. If there are any other questions, I would love to try and answer.
Awesome. Thank you so much, Itai, for the presentation and sharing all that and letting us watch you type in your commands and see how that went for you. So what questions do we have out there? Anyone have some thoughts or comments you want to share about a use case that this sounds amazing for, something you want to add to the conversation? We've got, just a little bit of time here before we wrap up. So get your questions out there now or chime in if you have some thoughts on this. And you're welcome to unmute or you're welcome to throw it in chat and I'll read it out for you. Okay, I'm not going to call names. It's okay if no one has questions. So we'll give it a few more, another minute of quiet and see.
Hi, I'm trying to wrap my head around using this with like an active a pipeline setup. So I have an upstream table and a downstream table, and I have a pipeline that I'm modifying data onto that downstream table, right? So if I want to make a change on that pipeline, what you're saying is I would do a version of the downstream table and the upstream table. Sorry. I would do a branch of the upstream table. Then I would develop my pipeline against that upstream table, the new version. I guess I also had to have one for the downstream table. And then once I'm ready, then I merge my downstream table version onto the main. Like I'm like trying to identify how we would use it for.
First, whatever works for you, right? You can have as many branches as you want. You can have for each table or for whatever serves your purpose, right? Branches are almost free, just a mere of a bit of metadata. And until you create different data and commits between the branches, nothing is created in your object store. Specifically for your use case, it sounds very typical where you create a branch out of the recent version of your production data. That's your isolation branch, right? You, I think that's what you referred as the up table, right?
Mhm.
And then you can run whatever transformation on it that you want until you're satisfied with the results. You can throw the changes away, revert them backwards if you found some problem with your pipeline, or once you're set, once you're happy with a single step, you can commit it and move on to the next step until you are satisfied with everything. The final result is what you usually want to merge back into production, okay, into your main branch. Again, once you're tested it and you're satisfied and everything works perfectly and nothing seems to get broken, that's the point. And guess what? Let's say that you did break the production. A single command line for Revert will bring you right to your previous version of your production, and you're good to go again.
Mhm. And so the standard process would be, once I'm satisfied with my update on my pipeline, I would merge the downstream data because now the output is outputting what I needed. I merged that onto to that table, and then I would deploy my new pipeline so that the production environment would then be on sync and doing what it needed to be doing.
Yeah, I think that's what you should do.
Yeah,
that sounds like the way we meant it to be used.
Mm-hmm.
I think that in general, you manage your commit strategy, right? And it can be, if this is an automatic pipeline that runs regularly, then the commit is not, the commit is for the entire lake. Or actually, let me rephrase that. The commit is for the entire repository, whatever the repository, whatever you want that repository to be, right? So it can be a setup of tables. It can be, sorry, combination of tables, and not only a single one. I want to differentiate between two things, which is in the data lifecycle. If we're talking about, let's say you have a multi-step Spark job and you want to now take step 7 out of 50 in that Spark job, and you want to add a metric to a table, then this allows you to branch out, develop that completely in isolation in something that's identical to production without doing anything wrong to production. And then you have your code, you have your development environment. But if this is something that runs automatically on a daily, nightly, whatever timeline, then what you'll want is you want to put commits throughout this process. You probably want to do this in a separate branch and then merge and then run some sort of quality check on the merge before when it goes to production, before or after. Can be with integration with quality check tools if you have any. But it's two separate things. One is the continuous commit, and I think Dustin asked before. Absolutely, you can have the end of the ETL job, have a commit automatically through the API that Itai mentioned, and that gives you the ability for the time travel. But following the question about Delta before, across the entire lake or across the entire repository, and not for a specific table.
Got it. Thank you.
Thank you, Ido.
Thank you for asking, by the way.
Yeah, I think it solves like one of the things that we deal with a lot is having to recreate our production environment so that we can test changes on pipelines. So I think it would help out to have that the ability to just easily create a copy of your data in a separate environment so that we can test that out before merging the pipeline to production.
Yeah, that's kind of at least part of the value I'm thinking of, Jesus, is you could create a branch to test out your different changes in code and see what that does to the data. And even if you're not, like, say your nightly job or hourly job keeps running and production's like way off from what you're doing now, maybe there's magic to merge it all, but even if you don't merge the data, you can test out the code and have this version that you could go back to and keep testing with without actually physically copy, or without having to copy the data and deal with just kind of the headaches involved there, especially if you can get a lot of times production and development or playground are kind of separated with S3 as well. And perhaps with this type of system and the force of merges into main, I haven't thought through it enough, but maybe you could like give more access to do experimentation within production, but only within these other branches, and doesn't just automatically get mixed in with what people are going to be querying for their production reports and exploration. So I feel like there's a lot of value there, but how exactly you implement, I'm still trying to get my head around too. So that's a good question. Any other questions or use cases where like, hey, this is going to be great, I'm going to go plug this into to my data lake tomorrow? All right, just checking. We do have a question coming in from chat. How are conflicts managed? Yeah, that kind of gets to where I was getting at. If you're trying to merge and there's a conflict, what's that look like? What do you do?
I'm super glad that this question was raised, mainly to the reason we just introduced a conflict resolution strategy feature. Up until a couple of weeks ago, our conflict management policy was we're not managing it. If you have a conflict, we fail the merge. We just implemented something similar to Git merging strategy, where you can specify as part of the merge if you would like to favor the source code, the source data coming from the source branch, right? You are merging branch, as we saw, merging branch testing into branch main. You can predefine that you would like to favor incoming changes from the testing branch into the main, and then upon a conflict, the testing version will be taken. Or you can decide you want the target version to be the favorite one, because I don't know, you don't know who may change the main branch, and it might be something you wouldn't like to override. And so if you specify that and a conflict does occur, you will take the version that exists on the main, or you can decide not to decide and let the merge fail. You will get a report of the differences and that the conflict was detected, and you can go and resolve it yourself if you don't trust us. I can only say that we're not doing anything, any magic underneath it. It's either taking version A or version B or none of them. A very recent version fix feature that we introduced, I think 2 versions ago, something like that.
All right, any other questions or quick comments from those out there? All right, well, he gave you the links to Slack and how to get in touch with him, so feel free to follow up. One quick announcement, and we'll get the official invite out before long, is that next month we will have Michael Kennedy coming, the host of the Talk Python to Me podcast, if you ever caught it. We'll have him joining us to share about 10 tips and tools for developers and data scientists. So that should be a really exciting one. We'll get that meeting out soon, so look out for that in your inbox, or wherever the heck you found about this one. Keep an eye out to find out about the next one. Any last comments from the lakeFS team? Thanks so much for joining us, from the Treeverse team, I should say.
Just come to our Slack channel to say hi.
That seems to be the way to go with open source projects these days. Jump into Slack, start talking to the people that are actually working on it, instead of wasting time searching for the right blog post. So appreciate the time, appreciate the presentation. I have this recorded. I should be able to get a recording up, and I'll share out the link through our meetup for those that missed part of it or have a friend that needs to see this. So thanks everyone. Appreciate you. Have a good night and we'll see you next month.